Hello guys, welcome back to my channel. So today we are going to study about our next programming question, that is remove last from the linked list. That means nothing but we have to remove the last element from the linked list. Okay, so for that what we have been given the question here and the same pattern. Right side we have the terminal. So we have the pseudocode already available and we just have to write the main method here. So I'll just remove that comments from there and I'll start typing there. So let's read the question. So it says implement a method called remove last that removes the last node from the linked list. Okay, so I'll create a method called remove last, and the return type should be node. So public node remove last. Okay, make sure you type the exact name what they have given, because they are going to use the same name in the main method. Like if you see here, remove last, so you have to make sure the name is in the camel case. Okay, so that's it. Now we don't need any parameters here, right? Because we have to just remove the element from the last node, so no parameter needed here. So inside that, what we have to do, first thing first, imagine the length itself is null. Then what will happen if length itself is equal to 0? So what do we do? So we can just return null, right? Because if there is no element in the 0, so what we can remove, right? Nothing. So that's it. That's the first thing, and that's the point one. Next, we have to create two variables to point to a node, that is temp and pre, both initially pointing to the head. Okay, so we have to create two variables now, that is node temp and pre. Okay, so these are the two variables which you have created, and they will all the node will the temp will point to the head, and the pre will also point to the head at the very beginning. Okay, so that's what we have to do. Next is we have to traverse. So basically what we have to do, we have to first go to the end of the linked list, right? So what do? We have to traverse it. Like basically traverse means you have to run a loop until the temp.next is not equal to null. So basically what will happen, we are going to stop when the temp.next is not equal to null. Okay, not equal to null, right? So we have to traverse till that point. Okay, that means when we are at the point when the temp.next will be equal to null, that will be our last node, isn't it? So that's the case. Okay, so traverse the linked list until temp.next is null. Okay, perform the following task. Then what we have to do, we have to just perform this following task. So what we are going to do ideally, the pre, that is the previous. Okay, pre stands for previous here and temp is the temp variable. So pre will be pointing to the, so basically pre to point to the current temp. Okay, then what we have to do, then temp will point to the next node of the linked list. Okay, so basically temp.next. Okay, after the traversal set the, okay, so what we are doing, pre is the temp. Okay, now before and then temp will be equal to temp.next. Okay, so we are first doing what, simply we are assigning the previous element as temp. Okay, storing the previous element as temp. Then temp is equal to temp.next is what we are doing. Okay, after the traversal set tail pointer to pre. After the traversal is done, we'll have to do what, after we have traversed, we have just write tail equals pre. Okay, then set the next attribute of tail to null. So tail dot next is equal to null, right? Decrement the length, because now we are popping it up, right? Because popping in the sense we are removing the last element. So the tail dot next should be what? Should be null, correct? And we'll decrement the length by 1 because I know that 1 has been removed. Now imagine if the length after removing becomes equal to 0, right? If the length after removing the node becomes equal to 0, that means what? There were just one element in the linked list. So I'll just point head equals null and tail also equals null. Okay, and then return the temp node, that is the node which is removed. Okay, so this is what it is. Okay, let's see and run the test cases to see if that makes any sense or we have any problems. That's amazing. That's all. See, what did we do actually? We took a pre pointer, okay, which was pointing to the head itself. Okay, and that is where we stored it temporarily as tail. Okay, and then tail.next we assigned it to null. Okay, so basically the element before the last one was assigned in the tail at first, and then tail.next we did it as null. That means there is no, the last element would be removed because the one previous to that is having the next pointer as null. Okay, then we decrease the length, and imagine if there was just one element in the linked list, the length would have become 0 by now, right? So if that is the case, then we just assign the head and tail to null because there is no element now in the head linked list, and at the end we just return the temp pointer. Okay, and that passes all the test cases. Okay, I hope you understand this lecture. If you have any questions, let me know in the comment box. Thank you.